Hi, welcome back to Maths Videos with Mr. Hanna. This is the last one in the Rates of Change series. Okay, what we're looking at today is the gradient of hybrid functions. So you remember hybrid functions are made up of several different parts of the function, each with their own domain. So here we've got a linear part with negative x for when x is smaller than or equal to 2. So that will be this bit down here. And then we've got this quadratic part here where the function is equal to x squared minus 6 when x is larger than or equal to 2. Now you know, you learned in the previous videos how to calculate the gradient at wherever you want on these different curves using the equation that says the gradient is equal to function x plus a little bit minus function of x all divided by that little bit of difference that you had from your point x. Okay, now that's totally fine for everywhere on this graph except for this pointy bit, okay, because this hybrid function is not perfectly smooth. There's a pointy bit here, and you know that it's pointy because the gradient coming from the left hand side over here is like going that way, looking like that, and the gradient from here is coming in, the tangent line looks like it'll be coming in at a gradient like that. Okay, so clearly the gradients don't match, and so because the gradients don't match perfectly, it's not smooth. If it was smooth, then the gradients would have to match exactly. So what we can say is, because they don't match exactly, there actually is no gradient. So let's make this statement. The gradient or slash the rate doesn't exist. It does not exist because the line is not smooth at x equals 2. In fact, the gradient approaching from the left-hand side gradient does not equal the right-hand side gradient at x equals 2. Okay, that's what you need to show if the gradient exists. So if we have a question that says something like prove that the gradient doesn't exist, so if we've got a prove question or a show that the gradient doesn't exist, show that, it's the same thing as prove, then we've got to calculate the left hand side gradient and calculate the right hand side gradient at x equals 2 and show that they don't exist, or that they're not equal to each other, I should say. Okay, so let's actually do that. Let's calculate the left hand side gradient. So, and we'll use our formula up here to do it. Now from the left hand side, our function is minus x squared. And obviously the x that we need to use, so this x that we need to use, this one here that we're referring to, has to be 2. So x equals 2, because that's the point that we're interested in here. So, and I'm going to use, so for h, it's going to be a small amount. So I'm going to use 0.01 for that. So let's have a function of 2 plus 2.001 minus the function at 2, all divided by that small bit, the 0.001. Now, like I said, our function is minus x, so what this is talking about is minus 2.001, take away 2 over 0.001. Oh, hang on, I made a small error. Whoops. Here we've got the function of 2, so that's actually minus 2. So we've got a minus going on there. So hopefully you can see that we've got a minus 2.001, minus and minus, so that's a plus. So we're going to have a 0.001 oh hang on, that's still a negative. Negative 0.001 divided by 0.001 is going to give us 1. Or wait, minus 1. So the gradient, the left-hand side gradient equals 1. Now let's check out, let's check out the right-hand side gradient. Okay, so we're going to use the same values. So our function at 2.001, take away function at 2, divided by 0.001. Now I could have used a different number from 0.001 if I wanted a different amount of accuracy. I could have gone for a 0.00001 if I had wanted to, just so you know. Okay, so here our function's a bit different this time. Our function is x squared minus 6. So I'm going to put my x values in for this x squared. So let's do that. So we've got our 2.001 squared minus 6. Take away 2 squared minus 6 over 0.001. Okay, so 2.001 squared. Let's quickly see what that is. 4.004. Shouldn't be too surprised. 4.004. That's actually rounded off a little bit, just so you know. Minus 6, minus 4, and then minus and minus 6 gives a plus 6, divided by 0.001. Alright, well the minus 6 cancels with the plus 6, and the 4 bit will cancel with the minus 4 bit, leaving us with 0.004 over 0.001, which equals positive 4. Now, you can see that our left-hand gradient is minus 1, and our right-hand gradient is 4. They're not the same, so all we need to say is left-hand gradient does not equal 4, which is our right-hand side gradient. So we have just proved that it's not smooth at that point. So we're done. Question over. And you'll have a few to do in the same way, but there are a couple of shortcuts that I think I'll quickly show you. Firstly, if you use your CAS calculator, you can just define your functions and then do this bit in one hit. So let me show you what I mean. I'll do it for this one here because it's a bit more complicated. So if I defined this function, x squared minus 6, so let's see, menu options. So we'll define this part, f of x is x squared minus 6. Now I can do that whole bit all at once, the bit that says function of 2.001, take away my function at 2. Now all this stuff divided by 0.001 is 4.001. There we go. So that's our answer 4 that we had a second ago over here. So we can use the CAS just to do the heavy lifting for us, so we don't have to bother doing all the algebra parts. So there's that way to do it on the CAS. Now there is also a second way to do it on the CAS, which is kind of cheating, but let's do it anyway. Okay, so first we'll define a whole hybrid function together. Okay, so let's define. Now let's look for our hybrid function, the one that has two parts, this one here. So it was negative x, when x is smaller than or equal to 2, and it was x squared minus 6 when x was larger than 2. syntax. What have I done? Something has happened that is bad. Of course. I've got to call it a name. F of x equals. Much better. Okay, now I'll graph that. F of x. There it is. And now I can just use my tangent lines, analyze graph. Oh, sorry, geometry, lines and points, tangent line. And if I select this line, now if you look at this, you can see that the gradient is clearly -1, because -1 is next to the x value. And it's always -1 because it's a linear line. Now as soon as I get here, look at this, my gradient's suddenly 4. And as I go up, my gradient's changing. So here it's 5.5, and it'll keep going out 6. So the gradient changes on that one. And right at this point, if I come from this side, it's 4, and if I come from the other side, it's -1. So you can tell that that it's not smooth using the CAS there. Alright, so there you have it, an extra way to do it on the CAS. Now, one final thought. Actually, no, I think that's all you need. So all done. That's all of Chapter 8, and we're done for the rates of change section. So best of luck, and see you in class.